Hello, my name is Charles Martinez. Today's date is October 23rd. It is approximately 4:05 p.m. and this will be my Circ 05, my attempt B. And in attempt B, making it better, we're going to be doing it the hard way and making the code switch the code from using the original coding. We're going to be changing from LED, or let me see here, it's update LEDs. It's not going to be update LEDs long. This is the piece of the coding that we did change, and I'll be going over that piece of the coding because we didn't earlier. We just went over this piece of coding here, which is going to be the next piece of coding. Will pretty much be doing the same thing, and that's going to be this one here, and we'll go over that, explain it as best as I can. We have the void update LEDs long, and this is going to be the loop that's going to be running, and it's going to be integer value, digital write latch low. We're going to have a for loop, and it's going to be the integer I equals to 0, and if I is less than 0, or I'm sorry, if I is less than 8, will be I++, which will be add 1. Integer bit equals value, and B 1000000. We use bit mask to select only the 8th bit in our number, and the one we are addressing this time, though we move 1 up on a bit value. So next time bit 7 will be bit 8, and we will do our math on it, and that's pretty much what that's going to be doing here. And the value is equal to value, and then you have your shift operator here, which is going to pretty much shift the 1 over to the left. And then we have our if bit is equal to 128, digital write data high. If else, if not, then it's going to be digital write data low. And then we'll have our digital write clock high. And pretty much what this clock is going to do is going to pulse. It's going to be the next 3 lines pulse the clock to pin. So this is going to be the pulse to clock to pin is digital write clock high, then with the delay. And then we have our digital clock low, which is turned off, and then we have our digital write latch high, and this one pulls the latch high, shifting our data into being displayed. The next piece of the coding here, let's see here, and these next pieces of the coding, these are going to be used in the bitwise math that we use to change the individual LEDs. Let's see here, and we have integer bits array, and we have B0001, and then we have B0010, and then you guys, you can see our 1 is shifting over to the left manually, and then we have integer mask, and then it's going to be B1110, and then we'll have our 0 shifting over, and pretty much the 1s are on and the O's are off. And then we have our void LED, integer LED, and then integer state, and this code here pretty much changes the LED, integer LED to integer state, changes the individual LEDs. The LEDs are 0 through 7, and is either O for off or on for on. And this is our change LED right here, integer state, LED and mask array. And this one clears the LED state of the bit we are addressing. And then if state on, LED state equals LED state, and bits array, LED array. If the bit is on, we will add to the LED state, and then it's going to update the LEDs in the LED state. Now it's going to send the new LED state to the shift resistor to update it. And this is the manual code. We're pretty much doing the same thing we did in attempt C. And the Arduino is pretty much identical, hooked up exactly the same, did not change anything, so it's the same as attempt C. So let's go ahead and plug it up, and then we'll go ahead and upload this new code with our changes that we made for making it better, and for doing the LEDs long. And we'll go ahead and upload it, and we'll get our little deal here, and then we should get our send and receive light up, and then we have our deal where we have our 1, our 2 plus 1 is 3, so we have our 4 now, and 4 plus 1 is 5, 4 plus 2 is 6, then we have 7, and then we have 8, and we have 9, and we have 10, 11, and then 12, 13, and then 14 and 15 to final, and then we're going to start over from 1 to 15. and we have our top LED sequentials going on, and every time they get filled up to the left, all the way filled up, then we'll go to our next binary number. And this was our attempt B, making it better the hard way, where we switched to use the LEDs long. And this is the coding, and yeah, it works. Everything looks good. Thank you.